Hello, my name's Josette Moss. If you should choose to come to Gateway, and we very much hope you do, I would be your psychology teacher. Students quite often ask about what kind of things you might do in psychology because it would be a new subject to you. So I'm just going to talk you through one of the activities that you would be doing in the second year. In the second year, you will be learning about localization of function. That means how your brain has different bits to it and what those different bits do. So to try and help my students embed that knowledge, what we do is we do a brain dissection and we use sheep brains. So if I'd like to draw your attention to the brain here, and you're probably thinking that all looks a bit squelchy, and it is. And that's because the brain is a very, very soft flesh, okay? This is really just fatty tissue. And when we get these sheep brains frozen, and when you defrost them, they sometimes lose a bit of their integrity. However, what we can see is a good example here of that's the pons, the medulla, and the reticular formation. That's your brainstem and the top of your spinal cord, this meaty bit here. And then this is half of a brain. So our brain is split into hemispheres, and you can see the central fissure just here. Okay, this is the brain on its side. This is the front of the brain, and this is the central fissure here. Okay, and you can see, if you imagine your brain is like a walnut, it's all connected all the way down. So this is the frontal lobe, and this is where you have your personality and where you do decision making. And behind that, we've got our temporal lobe, which is where you process sounds, and we've got the visual lobe at the back. And the visual lobe is for vision. Here we have the cerebellum, and this is for automatic processing. Altogether, this bit on the outside is called the cortex. So what we will learn about, if I turn my brain over, is we learn about the different bits of the brain and what they do. So this is a right lobe, okay, and if we turn that over, and we can see here, this is a very nice example of the different types of brain matter. We've got some grey matter on the outside and some white matter on the inside. And this is all the cell axons, so the bits that connect this bit of the brain to the other bits. Okay, so if I was to slice properly down my the middle of the brain, because this is already partially dissected, you can see that it seems to be connected by this white tissue. That is called the corpus callosum. And now I've severed the corpus callosum here. This bit's really important because when in psychology you'll be learning about people who have split brains. They're people who have two hemispheres that work independently of the other. And that's because they've had their corpus callosum severed to prevent epilepsy travelling from one hemisphere, one side, to the other. Okay? So if we look at this brain here, if we find a better example, or maybe I can, in the Malay, maybe I can find it here. Oh, in fact, I can see it here. So there are little ventricles in the underneath here in the midbrain. And what we'll learn about also is schizophrenia. And people who have schizophrenia have enlarged ventricles. And that death of the brain cells has been considered to be one of the causes for them losing certain aspects of their personality, losing functions like being able to speak properly, and also giving them irrational behaviours and thought patterns. So that's one of the reasons we might look at that. Also, this white rind here is called the Cingulate Gyrus, and we learn about the importance of the Cingulate Gyrus when we learn about OCD. And people with OCD often have a problem in the activation of the cingulate gyrus. Okay. So what makes us different from animals? Really, it's the outer cortex. So it's this thin layer on the top, okay, of the brain. And you can see in this brain here, we've got these little crevices. And if you just nick the skin, these crevices are actually little folds in the brain. And that's so that my brain can be as big as it possibly can be in the smallest space. It grows into folds, but it's nice and dense. Okay, so now we have a good example of the left hemisphere, which is the left side of the brain. And if we slice off the front of the left side of the brain, this section here is important for language. So people who have a problem with their left frontal side of their brain have difficulty producing speech. On the left temporal lobe, if we slice that up, okay, here we have Wernicke's area. So this sheep won't be able to understand language or be able to speak it. So research has been carried out onto people who have these natural splits between the two hemispheres, because it's like a walnut that's been split, but also research on animals when we scoop out bits of the brain. And although you can't see it here, we've got the hypothalamus and the pineal gland, and these bits here, if you can see them, that pineal gland, the pituitary gland, those are really important for things like our sleep-wake cycle. So if we were to scoop that out, there we go, this animal would no longer be able to go to sleep at the right time because he doesn't have a master clock. And we'll be learning about the rhythms, our biological rhythms as well. So all in all, we'll also be learning about memory and where different areas of the memory are stored. There are lots and lots of different functions of the brain, and in psychology we look at research and say, well, actually, is the function localized, or is it more to do with the whole brain? And what you would say is that, well, there is lots of evidence that the function is localized, because some of these bits of the brain have got really important parts to it, and if you slice it up, that person has a difficulty. However, there is lots of evidence that suggests that our function is not localized. For example, there is a case study of a small boy who had half of his brain removed at the age of 2.5. It was his left side, so effectively he shouldn't be able to speak. However, he developed full use of language and also had normal brain function. His right hemisphere took over the left hemisphere in its entirety, and there were no negative effects. So our brain must work together. I hope you've enjoyed that. I'm going to be doing a live session as well to support this and talk about psychology a little bit more, and you're welcome to ask me some questions. Thank you.